This video, Building the Cognitive Blueprint, explores how we can move from computation to cognition in the pursuit of artificial general intelligence, or AGI. The spectrum of AI ranges from artificial narrow intelligence, or ANI, focused on well-defined tasks, to artificial general intelligence, which matches human capabilities, and finally, artificial superintelligence, or ASI, which vastly surpasses them. Progress is classified across 5 tiers: emerging, competent, expert, virtuoso, and superhuman. Benchmarking AGI must extend beyond text. The Turing test assesses imitation. The IKEA test measures physical assembly. The coffee test evaluates novel navigation. And the Suleiman's test challenges economic autonomy. A key challenge for disembodied AI is the philosophical bottleneck. The symbol grounding problem asks how symbolic tokens gain meaning beyond other symbols. The parasitic mind suggests that computational models merely borrow meanings already in human minds, leading to a dictionary loop. We can escape this loop via sensory-motor grounding, shifting from ungrounded AI, a computational paradigm, to grounded AI using procedural semantics. The key insight is that to achieve true grounding, an agent must pass the robotic Turing test by interacting autonomously with physical objects and spatial properties. Intelligence requires a situated context. Anthropologist Lucy Suchman notes that all activity is fundamentally concrete and embodied. We must not separate thought from action, rejecting the computational brain in a vat model. Cognitive emergence results from the interaction of the brain, the body, and the environment. The social dimension of intelligence emphasizes the role of the social environment and cultural scaffolding. Lev Vygotsky stated that cultural development appears first socially, and then individually. True AGI may require an ontogenetic developmental period, learning intelligence through deep social immersion. World models are essential for engineering and internal imagination. This internal sandbox enables implicit representation of knowledge, anticipatory physics for learning fundamental laws, and forward-looking guidance for planning actions and reasoning under uncertainty. The architecture of an imagination engine involves 3 stages. Stage 1, the encoder, captures and compresses raw sensory data into a latent representation. Stage 2, dynamics modeling, predicts future events through self-supervised learning. Stage 3, the decoder, translates predictions into actions for robotic motor control. Spatial and cognitive AI encompasses several models. World models provide internal representations for future state prediction. Digital twins offer high-fidelity virtual replicas for risk-free testing. The metaverse blends realities for immersive interaction. And foundation models are broad neural networks for generalized representations. Imagination as computation relies on core capabilities: generating, which produces dynamically consistent temporal data; planning, which synthesizes anticipatory action sequences; and reasoning, which simulates what-if ripple effects to evaluate system-wide consequences of interventions. Next-generation edge intelligence addresses the edge constraint of intermittent connectivity and latency. Local imagination allows devices to complete observations and forecast futures instantly. Semantic compression transmits only task-relevant bits, shrinking spectrum usage. The result is fast, sample-efficient learning, without constant cloud validation. A case study with the wireless Dreamer UAV shows significant results. By integrating Q-learning with a latent world model, the drone anticipates weather internally. This approach achieves 46.15% faster optimal convergence and maintains an accuracy of approximately 5% error in reward prediction. The horizon presents a dual stake for general intelligence. On one side, unprecedented advancement promises scientific breakthroughs and an automated society. On the other, existential vulnerability poses risks, like mass technological unemployment, and the ultimate threat of losing human control. These risks demand caution, not abandonment.